So namaskar. I welcome all of you in TYBSC chemistry class. Today is our first lecture, and in today's lecture we are going to see overview of our third semester, TYBSC third semester. In today's lecture we will see the introduction of our physical chemistry syllabus in detail. So once again I welcome all of you. So this is the TYBSC syllabus. It is present on the SPPU Savitri Bai Phule Pune University website. So this TYBSC chemistry consists of 6 theory courses and 3 practical courses. Each theory course is of 48 lectures. 4 lectures per course per week are arranged. So there are 6 theory courses. Out of each theory course, it has 4 lectures. So 6 into 4 is 24 lectures per week. So in a week, we have 24 lectures. Out of 5 optional courses, we are taking only one course, that is the environmental course, since it is related to our day-to-day life. And 3 practical courses, they are separate practical courses: physical chemistry practicals, inorganic chemistry practicals, and organic chemistry practicals. Dr. Rahul sir might have told you about this yesterday. Now regarding marking, each theory paper will carry 50 marks, as this is the same like SYBSC syllabus. Each theory course was 50 marks. Out of 50 marks, 10 marks were allotted for the internal assessment and 40 marks were allotted for the external evaluations. Okay, 10 marks internal and 40 marks external. Out of 40, minimum passing mark is 16. Out of 40, minimum passing mark is 16, and out of 10, minimum passing mark is 4. Okay, 16 plus 4 is equal to 20. So out of 50 marks, you must achieve minimum 20 marks to pass the given theory course. Clear? You must achieve minimum 20 marks to pass the given theory course. Now let us move next. So one more important thing is that we have one small industry visit. Okay, and that industry visit is compulsory. So after lockdown we will arrange the industrial visit. And so why we visit the industry? Because we must know, so what are the jobs offered after BSc chemistry or MSc chemistry? What is the profile of job? So we want to give you touch about the industry, how industry works, and we have the industrial course in our semester. So for that, this industry visit is essential. Now coming in syllabus point of view, look at, we have 5 courses, compulsory courses, and 1 course is optional course. So out of 5, you need to choose one. So here we have chosen environmental and green chemistry. So these are the subject codes: CH331, CS332, 333. So first 3 represent third year, second 3 represent semester, and this one is for first course. These first 3 represent third year, second 3 represent third semester, and first is for the subject code. So third year, third semester, second subject, third year, third semester, third subject, similarly. So this is the optional subjects. So this is 6 paper. Now look at here, the number is 6. So understand these codes properly. In fourth semester we have the third semester, third year, fourth semester, first code. Okay, middle 4 represent the fourth semester, and here middle 3 represent the third semester. Okay, so what are the courses? First course physical chemistry, second inorganic, organic, analytical, industrial, and last one is the environmental and green chemistry. So each theory course have 48 lectures, and each theory course is of 50 marks course. Out of 50, 10 is given for the internal and 40 marks is given for the externals. Okay, so this physical chemistry course I will teach you Inorganic chemistry, Omkar sir will teach you. Organic chemistry, Dr. Rahul will teach you. Then industrial chemistry, this course Garje ma'am will teach you, and analytical chemistry, Omkar sir and me will take in part. Okay. So regarding practical course, so I will conduct the physical chemistry practicals. Dr. Rahul will conduct organic chemistry, and uh, inorganic, Omkar sir will conduct the inorganic chemistry practical course. So like SYBSC, we will have the annual pattern for the practicals. In annual pattern of practical will be 80-20 patterns. Okay, the practical examination will be conducted at the end of semester 4th. So at the end of semester 4th, exam will be conducted. Each practical course will carry 100 marks, out of which 20 marks will be allotted for internal assessment, and university examination will be conducted for the 80 marks. So the 20 marks of practicals are distributed as, so complete certified journal will carry 10 marks, and overall performance such as regularity, sincerity, submission of practical sheet on the time. So all these important point will be considered for your evaluation, and it will carry the 10 marks. Internal assessment for theory courses will be done on the basis of performance of the student in the test. Minimum 2 tests should be arranged. Okay. So here in internal, if you score less mark, then you can request us in writing, please conduct my new test. We will arrange a new test for you for your performance for getting good grades in the TYBSC. Okay, so this was the overview about the overall TYBSC third and fourth semester. Now let us move the next. Now physical chemistry course. Okay, course code is a 331. First 3 represent third year, second 3 represent third semester, and 1 represent physical chemistry course. So we have total 4 chapters in the third semester. Chemical kinetics, first chapter. Second chapter, electrolytic conductance. Third chapter, investigation of molecular structure, and fourth is a phase rule. Okay, these are the 4 chapters which we are going to learn in this semester. Now let us discuss about the first chapter, chemical kinetics. We are learning this chapter from our 12th science. Okay, in 12th science we have seen the basics of chemical kinetics. What are the basics? Okay, recapitulation means previous learning. Let us revise the previous learnings. So in recapitulation, just try to recollect, try to remember your 12 science lectures. So in chemical kinetics, we have seen what is meant by kinetics. Okay, kinetics means a study of motions, is called as the kinetics. So in chemical kinetics, what we don't study motion, we study how the reaction occurs. What is the speed of reactions, with what speed reaction occurs. We are going to study the speed of reaction in chemical kinetics. So there are some basic terms in chemical kinetics. What are the basic terms? What is meant by rate of a chemical reaction, rate law, what is meant by concentration, what is the unit of rate, what is the order, what is meant by molecularity, what is difference between order and molecularity, then zero order reaction, first order reaction, that up to this we have seen in the 12th science. In SYBSC we have seen further things. Okay, so first order reactions, its units, its derivation, its representation. Second order reaction with equal concentration, second order reaction with unequal concentration, and different methods to determine the rate of reaction. Okay, so now in this third year BSc we are going to see further thing, third order chemical reaction. Okay, so what is the order? The reaction whose rate depends on the number of molecules which are taking part in actual reactions. or we can say that it is the sum of the powers raised by concentration terms in rate law. Okay, what is the rate law? Rate law is the rate of reaction at unit concentration of the reactants. Then we are going to see third order reaction, definition, its example. Then we will move to the derivation of integrated rate law for the third order reaction with equal initial concentrations. So simple derivation we have. So don't worry about the derivation. You just recollect. If you want to master, if you want to learn the physical chemistry, then one must revise the previous basic concepts. Okay, so derivation we are going to see. Then we are going to see characteristic of third order reactions, example of third order reaction. Then important is methods to determine order of reaction using integrated rate equation method, graphical method, half-life method. Very simple thing this is. Okay, so it is a mathematical part, and we need a blackboard to learn these parts. Very simple calculations are this. Then this is an important topic, effect of temperature on reaction rate. As we know, we increases the temperature. What happens when we increase the temperature? Then molecule gets heated and their random motion increases multiple times. Due to increase in the motion of the molecule, their collision frequency or their probability of colliding on each other is increases. Okay, when the collision is increases, then there is chances of chemical reaction taking place. Okay, so when temperature increases, the rate of a chemical reaction, rate means what? The speed with which reaction proceeds, that is increases. Okay, so it is observed that this is a general observation, for every 10-degree rise in temperature, reaction rates gets doubled. This is a general statement. Remember this. Okay, this the question is asked in the entrance examination also. The reaction rates gets doubled at what temperature? So option are the T, 10 into T, 100 into T, and T square. Okay, so answer is 10T. So this is about the chemical kinetics. So what you must do at home, just gather your 12 science books, SYBSC books, and recapitulate each and everything, revise each and everything, so that you will enjoy this chemical kinetics chapter thoroughly. Okay, and one important thing that key, never go for new learning without doing its basics. First clear the basics and then attempt for learning advanced things. Second chapter is the electrolytic conductance. Okay, its basics we have seen in the 12 science also. So what is meant by electrolytic conductance? Okay, conductance means what is the Ohm's law? Okay, we have seen the Ohm's law. Okay, what is meant by current, what is meant by voltage, what are the units of current and voltage? Current's unit is ampere, voltage unit is volt. Okay, so it definition of ampere, it has been asked many times. Unit of resistance is ohm. Then conductance means what? Specific conductance, equivalent conductance, variation of conductance with dilutions and concentration. This is the important topic. You must revise that. Okay. Then when we take a salt solution and we dip an electrode in it, then we observe that current is flowing across the circuit. Okay, so why the current is flowing across the circuit? The current is flowing across the circuit is because of the ions, migration of the ions. Okay, so the migration of ions gives the current. So how ions are migrated in the solution? Okay, it is given by this law, Kohlrausch law. Okay, that is an important law. Okay, it is about the migration of the ions in an electrolytic cell. And these applications to determine equivalent conductance at infinite dilution of weak electrolyte, ionic product of water, and solubility product of the salts. Okay, so look at this word infinite dilution. Dilution means what? Just adding the excess solvent in it and diluting the content. Diluting content means that amount of the ions per unit area will be lesser and lesser. At infinite dilution, what is happening? Your weak electrolyte. Weak means what? The electrolyte which dissociates in less amount or partially, then such electrolyte is called as a weak electrolyte. Okay, so at infinite dilution means that when you take large amount of solvent, then all the weak electrolyte molecules gets completely dissociated. All weak electrolyte molecules gets completely dissociated. Okay, so that is the concept of the equivalent conductance at infinite dilution. In equivalent, what is the word meaning of word equivalent? Equivalent means certain quantity, fixed quantity per unit volume of the your electrolyte. Okay, then next let us move to the next part, migration of the ions and ionic mobilities. So as I told you that, okay, when current flows across an electrolytic cells, then it is because of migration of ions. So this is about the how the ions are migrated and their ionic mobility. What are the factor on which ionic mobilities are dependent, that we are going to see. Then absolute velocity of ion transport number. Transport number is nothing but the amount of electrons flowing, amount of current or electrons flowing across the circuit per unit area, and that. Okay, so this is so little difficult part, Hittorf method and moving boundary method. Relation between ionic mobility, ionic conductance and transport numbers. So this is more important topic, ionic theory of conductance. Okay. It is proposed by Debye, Huckel and Onsager. They developed the equation, famous equation, and the equation is known as Debye, Huckel and Onsager equation. Okay, so that we are going to see. Then there is one more concept of activity and fugacity. So activity means that, let us take the example of there are 100 students in the classroom. Okay, 100 student in the classroom. So let's say 100 student is the concentration of the classroom. Okay, let us put in different way. 100 students are the actual, sorry, this is the concentration of the class. So concentration of class is equal to 100. Okay, now when teacher enters in the classroom and starts teaching, then out of 100 only 80% students are attentive and they focus their attention on the learning process. So these 80 students are the actual students who are or who gets engaged in the learning process. So we call this as, here we call this as activity is equal to 80, concentration is equal to 100 and activity is equal to 80. It means that not all the molecules participate in a chemical reaction. Only certain amount of molecules get participates in the chemical reaction, and this number of molecule is called as the activity. Okay, you might be getting some hint about this. So fugacity is this concept about the activity extension, activity coefficient for the strong electrolyte. Strong means the electrolyte which gets dissociated completely. What is meant by electrolyte? The solution which conducts electricity. The solution which conducts the electricity is called as electrolyte. You might have seen the movie Three Idiots. Okay, just remember the Amir Khan's incidents when the Amir Khan enters in the hostel and the senior starts harassing the Amir Khan. Okay, in that movie, Three Idiot movie, and what he does or what he does, you just observe the scene. Okay, just recall the scene, then you will come to know that the electrolyte, ionic conductance, ionic electrolytes. Okay, so let us move to the next part, that is the investigation of molecular structures. So molecular structure, water have the V-shaped structure, methane have CH4 structure. Okay, PCl5, phosphorus pentachloride, it has a trigonal bipyramidal structures, so on. Okay, so how in chemistry the molecular structure of molecule is determined? This is the basic questions. Okay, there are different techniques: IR spectroscopy, infrared spectroscopy, ultraviolet spectroscopy, NMR. Okay, nuclear magnetic resonance is there, and the molecular spectra: rotational, vibrational, Raman spectra, microwave spectra, electronic spectra, and so on. Okay, so in MSc you will learn details about this molecular structure. Here we have the introduction. So in this chapter we must know what is meant by some basic phenomena of light: refraction phenomena, reflection phenomena, diffraction phenomena. So refraction means what and reflection means what, that we are going to see in this chapter. Molar refraction means, molar means 1 mole. Okay, amount of refraction given by 1 mole of a solution is called as molar refraction. Then comes the concept of the polarity concept. What is meant by polarity? Okay, polar molecules and the non-polar molecules. Polar molecule means what? The molecule in which the charge separation takes place under external electric field, then such molecule is called as the polar molecule. Non-polar molecule, the molecule in which the charge separation is not taking place under the influence of external electric field, then such molecule is called as non-polar molecules. So how molecular gets polarized? That's theory we have, polarization theory. Then dipole moment. Di means two, pole means two pole, positive and negative pole. Okay, it has the moment. Moment means some direction and magnitude. Okay, this is the physics concept. Determination of dipole moment, then molecular spectra. Okay, this is very important topic. Okay, this is most lengthy chapter of this third semester. It takes around 20 lectures to finish this topic efficiently and effectively. So in molecular spectra we have the rotational spectra, vibrational, and Raman. Okay, what is this? Okay, molecular spectra. Okay, so when you take molecules and put in microwave region, what happens? Okay, as soon as if molecular is polar and it interact the microwave radiation, then the molecule starts spinning around itself. Molecule starts spinning around itself. Okay, and it absorbs certain kind of energy and emits some energy. So amount of energy absorbed gives rise to gives us rotational spectra. Similarly, vibrational and Raman. In MSc Master Science, you have NMR, nuclear magnetic resonance, then microwave spectroscopy, Mosbor spectroscopy we have, electronic spectroscopy of atoms. Okay, very nice techniques we have in the masters. Now let us move to the last chapter. Last chapter is a phase rule. Phase rule. So what do you mean by phase? We know matter exists in solid, liquid, and gaseous form. These are the three phases. Okay, so how phases are interlinked with each other. Okay, this is what we are going to learn in our syllabus. So what is meant by phase, what is meant by system, what is meant by components? These are basic concepts associated with the phase rule. Then phase rule is proposed by Gibbs, scientist Gibbs. Okay, then phase rule for one component system such as water, phase rule for two component system, silver lead and zinc cadmium mixture, that we are going to learn. So this physical chemistry is the simplest syllabus, provided you attend all lectures sincerely, honestly, and you must do the given assignment in proper time or within the time frame. So some important thing about this physical chemistry course is that, okay, this course is not like other course. You must involve yourself in learning process. When you start reading, then the question will arise in your mind, and when the question arises in mind, then and only then the learning process happens, learning process takes place. Now let us move toward the analytical chemistry syllabus. Dr. Rahul sir will teach you the organic chemistry. So he might have taken introduction of organic chemistry. In organic chemistry introduction, Omkar sir will take, and now come to the analytical chemistry syllabus. CH344. Yes. This is a third semester course. Look at the symbol. Third year, third semester, fourth course. We have total 6 chapters. First, gravimetric analysis, thermal method of analysis, spectrophotometry, polarography, atomic absorption spectroscopy, and flame emission spectroscopy. So this first 2 chapter Omkar sir will teach you, and remaining 4 chapters I will teach. I will conduct this remaining 4 chapters. So gravimetric analysis mainly concern about the precipitation techniques. So in this chapter we are going to learn what is meant by precipitation, co-precipitation, what are the factors which affects the precipitation process. Okay, condition for precipitations, how to minimize the co-precipitation means during precipitation the impurities gets adsorbed on the precipitate molecules, so impurities also gets precipitated, then such process is called as the precipitation process. So when we precipitate, there are washing techniques. So how to wash the precipitate, how to find out the best suitable solvent mixture pair so that our precipitate will not dissolve in the solvent or solution. These are the conditions which we are going to see in this. There is one small topic, electrogravimetry. Okay, so this topic we have seen the in 12th science, electrogravimetry techniques. Now let us move to the next, thermal method of analysis. So when we heat any molecule, then it undergoes decomposition such as weight loss, molecular changes, such as, okay, like this. So we are going to see the effect of temperature on the molecules on the sample weight. So we have this 3 technique: thermal gravimetry analysis, okay, differential thermal analysis, what are the factors affecting the thermal analysis, and some numerical problem. Okay, simple and very easy topic. Now next chapter is the spectrophotometry. Okay, in SYBSC some part we have seen spectrophotometry. Okay, photochemistry chapter we have learnt this chapter. So learn some basic concept from that. Okay, what is meant by absorbance, transmittance, Lambert's law, Beer's law, optical density, units of optical density, Lambert's Beer's law, and so on. So here mainly focus is about the spectrophotometric analysis, instrumentation of the single beam spectrophotometer, double beam spectrophotometer, and like that. Then what are the detector used in the spectrophotometers? Spectrophotometric titrations, experimental application, structure of organic compound, and so that. Okay, so in physical chemistry practicals we have around 5 practical which depends on the spectrophotometric titrations. These are the normal titration, okay, which you have performed in the laboratories. Next is the polarography. Now this technique is used in industry to find out toxicity of the heavy metals. Suppose person engulf or accidentally engulf heavy water, poison water, then scientists use this polarography technique to find out concentration of that heavy metal ion in the person's body fluids. So, what do you mean by polarography? What are the electrodes used in the polarography? There are two type of electrodes: dropping mercury electrode and saturated calorimer electrodes. Its working and instrumentation of polarographic apparatus, Ilkovic equations, quantitative analysis, polarigram, and so on. Okay. This is the 8 lecture topic. Simple topic. This topic is very simple. Chapter is very simple. Now last two chapters: atomic absorption spectroscopy and flame emission spectroscopy. Okay, these two techniques have similar principles. Similar principle. Okay, when in this technique, what is happening? You are injecting liquid sample in a compressor, and the compressor atomizes the sample into small liquid droplets. In this technique, the liquid droplets comes in a high energy flame, and due to this they gets activated. Activated means what? They absorbs energy from the flame. So due to it is called as atomic absorption spectroscopy. How much amount of energy is absorbed is calculated. Here, when the atoms goes in the flame, they absorb energy and they emit the radiation. So it is called as flame emission spectroscopy. So details we will see actually in the class. So for today it is enough. From tomorrow onwards we will start from the physical chemistry syllabus. Okay, till then, bye bye, thank you for listening.